All right, so this is an introduction to static electricity. I promise it will be shocking. All right, so to think about static electricity, it's helpful to first think about the atom. So those of you that took chemistry prior to taking physics this year should recognize this conversation about the atom. You also should have seen it in other previous science classes, like physical science, perhaps in middle school. All right, so a brief history of the atom is a long time ago, somebody named Dalton created his Dalton model of the atom. He thought that atoms are building blocks of matter and there is nothing smaller than the atom. Sometime later, a scientist named J.J. Thomson, was given credit for his model of the atom, where he said, well, there are actually things smaller than an atom, that an atom has negative charges, which we now call electrons, and those negative charges are embedded in a sea of positive charges, which we now call protons. But they're all kind of mixed around. Later, somebody named Rutherford created a model of the atom where he said, well, the positive charges, there's actually a little bit more structure. The positive charges are located in the central nucleus, and then the electrons are more free to move outside of that nucleus. And then, not finally, but after that, somebody named Bohr created a model of the atom where he said, well, the electrons aren't totally randomly moving outside of the nucleus, that these electrons have circular orbits with different energy, where the different levels that they're at have different energy levels. And then that leads to a more recent view of the atom called the quantum mechanical model that says, well, electrons actually occupy certain regions or electron clouds, and different energy levels have different shapes. And so an electron, for example, could be moving where you see the cursor anywhere between here and could be there at any place at any given time, or could be going here. There's different shape and different number of electron clouds that exist depending on what element the atom you're talking about is for. All right, so that's a brief history of the atom. So we've got an atom, and the atom is composed of protons, electrons, also neutrons. Some key takeaways, there's other details with atomic structure, but for us, that's good enough. There are other key takeaways here are that protons are tightly held in the nucleus, and that an atom of a given material cannot gain or lose protons and still be the same substance. So if you have carbon and you add a proton to carbon, it will no longer be it will no longer be carbon. So protons are tightly held, and you cannot gain or lose protons. Basically, protons don't move. The second set of key points is that electrons move around and are less tightly held within an atom. So an atom can gain or lose electrons and still be an atom of the same substance. So if carbon loses or gains an electron, it's still carbon. It will just have a positive or a negative charge. So electrons do move. So this is very important for what we're going to be doing, because we're going to get to examples where you try to figure out how does something become charged, or how does positively or negatively. And in every case, the protons are not going to move. It's the electrons that will move. So along these lines, or building off of this, is the idea of insulators and conductors. There are some materials that are insulators and some materials are conductors. So what are those terms? Well, an insulator is a material through which current does not easily flow. So electrical current charges electrons. Electrons do not easily move from one atom to another atom in an insulator. In a conductor, however, electrons can very easily move from one atom to another atom. So You see on the screen here some common examples of electrical conductors. Lots of those are different examples of types of metal, silver, gold, copper, steel. But you also see seawater. Seawater has salt in it, and that makes it also, conductive. You also have some electrical insulators, so dry wood, diamond, oil, glass, rubber. And that is where we're going to pause this segment of an introduction to static electricity.